Well, hello guys, here Mr. G with another video. This one is going to be question 9 from the June 2023 done in the Northern Cape province. Paper 2 and set B. This one is about stoichiometric. It's a very important topic for the grade 12. It is a good question. Let's see the question. The question says 4 grams of sodium hydroxide pellets were dissolved in 250 cubic centimeter of water. When 30 cubic centimeter of this solution were titrated against a solution of sulfuric acid, so we're working here with titration, and note the following. This one is related to the grade 12. So if you are in grade 11, you are going to need this one for grade 12. And if you are in grade 12, then you did this one in grade 11. Okay? Now, the volume of sulfuric acid obtained at the end point were recorded as in the table below. And here's a table with all the recording of the experiment. Then furthermore, the question said the balance equation for the reaction between sulfuric acid and sodium hydroxide is given below. A note here is this symbol that you see here is a mistake with the computer when the computer was converting the process. That is an error there. Calculate the concentration of sodium hydroxide solution. Now for this question, all you have to do is to see what we have here. We have the mass, we have the volume of water in which the sodium hydroxide was dissolved, and then all we have to do is to calculate the concentration. So for that work, the answer is very simple. All we have to go is to the formulas here. In the paper 2 you have very little formulas, and they are formulas that can be used. You can use this formula for concentration. However, this one can be used as well, but if you use that one, you have to calculate the number of mole first. So it doesn't really matter. Let's use the second one, and let's quickly write here what we have, just to make sure we know. Question 9.1. So data, what we have here. We know that the amount of sodium hydroxide that was dissolved was 4 grams. So mass of the sample, this is sodium hydroxide, NaOH, is going to be equal to 4 grams. What else they giving you here? It was dissolved in 250 cubic centimeter of water. Volume in which this was dissolved was 250 cubic centimeters. Remember, you cannot work in cubic centimeters, so we convert, and in this case we're going to divide by 1000. I'm going to write just in case somebody don't remember. This one is 0.25 cubic decimeter. It is important to know that you have to convert. Okay, what are the data we have? That's it all we need. Now we need the molar mass for sodium hydroxide, NaOH. So let's look for that one real fast. Now to do that one, you quickly have to go to the periodic table. You will get that the molar mass of sodium is 23. The molar mass of oxygen is 16, plus hydrogen, which is 1. And the answer therefore is 40 grams per mole. That one is the molar mass of sodium hydroxide. Guys, from here we have to calculate the concentration. We already did look at the formula, so concentration is equal to mass divided by molar mass multiplied by volume, which is everything we have. Concentration is equal to 4 grams divided by the product of 0.40, which is the molar mass. Let's write the 40 first, but it doesn't really matter. Multiplied by 0.25. There we go. So concentration, when you do this simple calculation, guys, you will get 0.4. Let's write that 0.4 properly. 0.4 mole per cubic decimeter. That is the unit for concentration. Guys, we know now the concentration of the sodium hydroxide, which in this case is the base. So remember here, in this case, the sodium hydroxide is the base and the hydrochloric acid, sulfuric acid, pardon, is the acid. It goes like this. This is the acid. And you should watch some of the videos to know the acid-base conjugate pair, but in this case, the sodium sulfate here will be the conjugate base so it goes like this one, is this one and that one there, and then the other one is the H2O, which is the conjugate acid, and this go like this. But the guys, this is not part of the question. I just write in there in case you want to know. Now, question 9.2, calculate the concentration of the sulfuric acid solution. Now, to do this one, we are going to use titration, but remember, all the data are here. So you can see that the volume of the sulfuric acid at the end point was 25 in all the trials. There you go. So all we're going to do is to use the titration formula to calculate the concentration of the sulfuric acid. So this is question 9.2, and we have everything now there. So let's write data real fast. In this space, I think is enough space for us to answer. And what we have, first of all, the concentration of the base, I'm going to write Cb is equal to 0.4 mole per cubic decimeters. We have that the volume of the base that was used, go to the question back, and they say they use 30 for the centimeter of this special one, the base in this case. So it was 30 centimeter cubic. Guys, remember, in titration you do not have to convert, okay? 30 cubic centimeters. And then the volume of the acid, guys, it is in the table. You can see that it was 25 at the end point for each of them. So it is 25 cubic centimeters, and they are looking for the concentration of the acid. There we go. So all we do is we go to here and we look for the formula of titration, which is this one there, and we must write it exactly like that. So this is the formula that can help us to do some calculation of titration. It is important for grade 12. In grade 12 you'll do a little bit more, but that is for now very important. So it's Na divided by Nb equal to Ca Va divided by Cb Vb. The way you write in this formula is not a big problem, but is there. Now, important, just to start substituting, this Na and Nb are the ratios. They are the ratios. Let's write that word, the ratios, better. They are the ratios, and the ratios are in the equation. The ratios are 2 for the base, 1 for the hydrogen sulfate or sulfuric acid. The ratios are the numbers at the front. Okay, so the ratios are the following, and we're going to start substituting the ratios rather. For the acid we have 1, for the base we have 2. You can see it there, guys. It is in the graph. 2 for the sodium hydroxide, 1 for the sulfuric acid, and then the rest is just substituting what you have. Concentration of the acid, we are looking for that one. Volume of the acid is 25. We are not going to convert. You don't have to convert in this formula as long as all the volumes are given within the same unit. Now, for concentration of the base, we have 30 multiplied by the volume of the base, which is pardon, I make a mistake here. For the concentration we have 0.4, and for the volume we have 30. There we go. So now this calculation is very simple. All I'm going to do is to rearrange it quickly for you all, Ca is going to be equal to 0.4 multiplied by 30 divided by 2 times 25. Okay, so that's all you are going to do, and this is a very simple calculation, guys. And then the answer for the concentration of the acid is 0.24 mole per cubic decimeters. Guys, this is all for now. This is a very important question about stoichiometric. Is important for the Cray 11 as well as the Cray 12. So I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.